It's David here from Site3D, and I'm going to quickly show you Deepbore Soakaways in Site3D. So here we have a network that I've already put in, and it drains through to a pond and back out with a hydro brake to back everything up. I want to insert a Deepbore Soakaway at manhole S16. To do this, we go to the manhole properties. We're going to go and click the manhole properties button and select S16, and we're going to change its type from chamber to Deepbore Soakaway. Once we do that, we can then specify the properties of it. So we have the actual the borehole diameter, that is the actual diameter of the shaft that is cut out of the ground. We have the pipe diameter, that is the diameter of the pipe that is put down through that shaft. We have the invert of the entire Deepbore Soakaway part of it. So this should be something quite low, something like 5 meters, considering we have our invert level of the chamber at about 12 meters, 12.5 meters. We have the height of infiltration above the invert, so that is about 1 meter in this particular case. We could change that to say 2 meters or something like that. We have the infiltration rate of that infiltrating height and its safety factor as well. And then we also then have the fill porosity. So this is the granular material that is at the bottom of the borehole that goes between the 150 mil diameter of the pipe and to the 300 mil diameter of the actual shaft that is dug out of the ground. So once we've specified all those properties, we can click OK, and then we can go and run our simulation. So I'm going to go to our drainage analysis tools, hit run storm simulation. We can choose the particular durations and return periods that we're interested in and the rainfall types, but basically just hit run simulation, let it go through all of those storms, click the view report button to show the actual PDF results. And in here we can see we have our manhole schedule, our pipe schedule, our paving area schedules and everything like that. But we also have our Deepbore Soakaway information in the flow control details. So here we have the actual chamber invert, the chamber diameter, so that's the actual manhole that's on top of the actual borehole. Then you have the pipe diameter of the actual shaft that goes down. We have the invert of the borehole. We have the main shaft, the actual part that's cut out, which is 300 mil. We have the height of infiltration, and we have our infiltration rate and safety factor and fill porosity. Underneath that, we also then have the depth to duration performance graph of the actual soakaway. In this case here, we can see it quite quickly fills most of the way up and then fills the last section up and then comes back down again as well. And this is maxing out at 8.6 meters at the 690 minute mark on a 100 year at 40% climate change with a 720 minute winter storm. This is basically the worst case scenario on this particular one. Thanks for watching.